It's Andrew Wood, and this is the Physics 2212 Lab 2 Lines of Charge. Introduction. The purpose of this Lab 2 is to complete a computational model in GlowScript for finding the electric force of two charged tapes exert on each other. The model will be finding the electric charge of many points on the tape instead of assuming that the piece of charged tape is a single point. Results preview. The electric force calculated was to be 1.962 e to the negative 3 newtons. The charge on one piece of tape was 2.32 e to the negative 9 coulombs, and there was a calculated 28% difference between the two charge values. Physics principles. We'll be using Newton's second law, which is force equals mass times acceleration, electric field between 2-point charges formula, which is shown in the picture in the top right. The electric force formula, which is electric force equals charge times the electric field, where Q is the charge and E is the electric field, and the superposition of fields, which is all fields acting at a point can be summed and act as one field. Lab 1 information. The properties of my tape from Lab 1 were the length was 20 centimeters, the mass was 0.2 grams, the width of it was 2 centimeters, and the distance when it started floating was 3.75 millimeters. Tape B was the system and tape A was the surroundings. The results from Lab 1 were the electric force was 1.96 e to the negative 3 newtons, the charge on one piece of tape was 1.75 e to the negative 9 coulombs, there were 4 e to the 17 atoms on a piece of tape, and the deficient electrons per atom were 2.725 e to the negative 9. Lab code. So in the left picture, they're all my physical constants, with my length being expressed as 0.2, width as 0.02, and d, which was the distance between the two pieces of tape, was 0.00375. The UFPES variable is what we know as k, or 1 over 4 pi epsilon naught. I then also added the mass of my tape in kilograms and the estimated net charge on one tape. On the right side, I have my E-field equation, which is R equals observation location minus charge particle position, the R magnitude, R hat, Q equals charge particle charge, and then E is the formula for finding it. Lab code part 2. In the bottom left, that is the function that we were given that creates the line charges and sets the position and spacing and the basic what we used for this lab. In the top right, that is a formula for creating the tapes and is used to model the collection of charges that we will be using as quote-unquote tapes here. I edited the vector positions for the starting position and the axis positions for the top and bottom tapes to fit my position. Lab code part 3. So this is the part where we use the formula to calculate the electric force on the top tape due to the bottom tape. On the second to last and last lines, I edited in what the force on E field on DQ top by DQ bottom, and added the E field parentheses DQ underscore bottom, comma DQ underscore top dot pause. In the bottom picture, I edited the axis of the arrows so that the arrows would show in the proper directions, as well as adding the magnitude and displaying the right numbers. This is the final model I achieved after running my code, with the magnitude of the electric force being 1.962 e to the negative 3 newtons, and the magnitude of the gravitational force being 1.962 e to the negative 3 newtons as well, because these forces are equal and opposite. The charge on one piece of tape was 2.32 e to the negative 9 coulombs. Errors and assumptions. Sources of error for the Lab 2 will mostly come from Lab 1 and the collection of data there because Lab 2 is entirely coding. The sources of error would still be the tapes having different charge and losing charge passively over time. Assumptions. We are ignoring air resistance, taking the third 3D object as a 2D line of charges, and assuming the charge of the tape is uniform throughout. What if? The line charge that we found was 2.32 e to the negative 9 coulombs, and the point charge is 1.75 e to the negative 9 coulombs. The value of the tape being calculated as a string of charges has a 28% difference between the two values and is more accurate than modeling the charge as a single charge. Why? The estimates differ because the formulas used to calculate each differ. Modeling the situation as a line is more accurate than having a single point charge because it adds a more realistic dimension to the calculations, 2D versus 3D. And this has been my Lab 2 lab report.